Welcome to the second session of Basics of Projection of Line. We already discussed 5 sections and now the sixth topic, that is sixth position of line. The line is inclined to both HP and VP. So this may be the case. Here you can see this line is inclined to HP as well as it is inclined to VP. It is making angle with both the planes HP as well as VP. So in that case we have to rotate the lines and make it parallel to one of the surfaces, and we have to rotate it to get the views of the line. So that answer will be drawn like this. So I'll show you the answer, how the answer will look like. So what is the procedure we are going to do for the line which are inclined to both HP as well as VP. So first of all we have to draw this XY line. Let us say this is locus of A dash, locus of B dash, locus of A, and we can write locus of B. So locus, that means on that particular point we can take any point. So on this particular line we can write A dash anywhere, right? A dash, A1 dash, A2 dash. So say for an example this will be our A dash point. So A dash and A will be in same line. So let us say the projection lines are this, so that we have this point as our A point, right? Now for true length, say for an example our true length is A dash to B dash. Let us write it as B1 dash. Let us assume that this is our true length. So the angle made by true length with horizontal plane is written as theta, right? Now let us draw the plan length. So for plan length we can write like this, draw like this, right? So this will be our plan length, okay, as we have seen it in the first case, right? From this true length we get the plan length, right? Similarly we are going to take a length of elevation length. From this true length we are going to find this elevation length. So first this is our plan length. So what we are going to do now is we are going to rotate this length like this, right? Keep A as a center and let us assume this point as A1, right? Let us assume this point as A1. So take A as a center, A1 as your radius. I am writing over here A as a center, A1 as our radius, and we'll draw one curve up to locus of B, up to line of locus of B. So this particular line is called as your plan length, right? And the angle which is made by the plan length with the VP is called as beta, right? Fine. So now let us assume that we have one another length, that is true length. Okay, so I'm drawing this true length. Let us write it as B2, right? Let us write it as B2. It is also a true length, and the true length which makes an angle with VP is called as phi. So I'm writing over here is phi. Now how to get this elevation length? We have drawn elevation length over here. So what we have done is we have taken projection of this 2 point in the upward direction, or you can say it is in the front view. So from that let us just draw our vertical line from here. Okay, so you can see it like this. I have drawn one vertical line. So this point, let us assume that this point, say for an example we call it as say for an example we call it as A2 dash point. We call it as A2 dash point, right? Now what we are going to do is we are going to rotate this line, right? Take A dash as a center and A dash, A2 dash as a radius. Take A dash as a center and A dash, A2 dash as a radius, and rotate it with the compass, right? Rotate it with your compass. So it will rotate like this, right? You can rotate in this direction. So you'll get another line. So this line is called elevation length, and the angle made by this line is called alpha. So this is the way you can draw the projection of line which is inclined to both HP and VP. Now you have to grasp or remember this particular figure, right, for solving any sums of projection of line, right? So I am giving you the glimpse of that. You have to grasp this particular figure and what are the notation that has been used in this particular projection of line. So I'm showing you that, and you have to understand and you have to grasp all that thing. You have to remember all of these things, right? So say for an example, this will be the answer of your projection of line. So this looks like this. Okay, so this will be A dash and A point, this will be B dash and B point. Now what we have seen is A dash, B dash, it is your elevation length, AB is your plan length. You already know how you got this. A dash, B1 dash is your true length, A, B2 is your true length. Now how to get each and every this line? Okay, so if you have this true length, you have to extend it up to this point, right? And you have to then rotate it, take A as a center and A1 as a radius, and you have to rotate it up to locus of B so that you can find plan length. Similarly, if you have this true length AB2, then you have to extend it up to this particular point, right? Take A dash as a center and A dash, A2 dash as a radius, and take the curve and extend it up to locus of B dash, right? So that you will get the elevation length. Similarly, you can find each and everything. Now the notation that has been used in this particular figure are somewhat like this. Okay, the theta, it is the angle of true length with horizontal plane, as I already discussed, that is angle made with front view. And similarly phi, theta, it is angle made with front view, it is horizontal plane angle. Angle phi, angle made with true length, you can see that with the green line it is true length, and the angle made with true length phi. Okay, this is by the vertical plane, or you can say the top view. Similarly, alpha and beta are, so the angle theta and phi, it is also called as true inclination or true angle, right? It is a right angle, exact angle will be there, same as in the case of true length, right? So alpha and beta, it is angle made by elevation length and plan length respectively with HP and VP respectively, or you can say with front view and top view respectively. These alpha and beta are called apparent inclination, right? It is also called as apparent inclination or apparent angle, it is also called alpha and beta. So alpha is angle made with EL, beta is angle made with PL, right? Okay, so what is TL, EL, PL? As I already told you, TL is true length. I have given the notation A dash, B1 dash. Here you can see A dash, B1 dash, it is your true length. A, B2, it is your true length. A, B2 is also your true length. Elevation length. Now you can consider this A dash, B dash is your elevation length. But as you can see, we are rotating this A dash, B dash up to this point. So this A dash, A2 dash also is your elevation length. And we are also extending up to this A2 point. So this AA2 is also your elevation length. Here you can see that AA2 is also your elevation length, and your plan length will be AB, AA1 and A dash A1. So your plan length AB, you are rotating it. So AA1 and your A dash A1 dash is also your plan length, right? Now you have to keep certain points in mind for solving this, that true length is always greater than EL and PL, and alpha is always greater than theta, beta is always greater than phi. You can see that alpha is greater than theta, beta is greater than phi. True length is always greater than this EL and PL, right? Right. Okay, fine. Now for solving this, you have to keep another point in mind, that what we are doing is, we are, for solving this particular problems of projections of line, we are extending this true length. First, what we are doing with true length, you can see in this figure, this is the true length. We are extending this true length up to this point, right? If you have the true length first, then we are extending it up to this point. After that, we are rotating it, right? After that, we are rotating it. Or in the case, if you have this plan length, then we are rotating it first, and then we are extending it. Let's see another time. If you have a true length, then we are extending and then rotating. If you have a true length, then we are extending and then rotating, right? So if you have true length first, you have to extend it first and then you have to rotate. Now in the opposite case, if you have elevation length or plan length, you have to rotate first and then extend. If you have elevation length, you have to first rotate it and then extend it. If you have plan length first, then you have to rotate it and then you have to extend it. So I have written this formula for that, how to and up to what point you have to extend or rotate. So if you are at 8 B dash point, say you can see here, if you are at B dash point, you have to find the opposite of B dash, that is A dash. And what is the other view of A dash? That is A, right? So you have to extend the line from B dash to A point, right? So I have extend this B dash to A point, right? You have to locus from you have to extend from locus of B dash to A, right? See second, if you are extending the line which is at point B, so what is the opposite of B? That is A. Now what is the other view of A? That is A dash. So you have to extend the line from B to A dash, sorry, you have to extend from line from B to A dash. See here, from B to A dash, then you have to rotate it. Now for rotation formula, for rotation we are rotating up to its own center or opposite of the other. What does that mean is, if you are at A dash, okay, so you are rotating from A dash to B dash. If you are at A dash, you are rotating from A dash to B dash. Or if you are at other point, take center A, B dash to A dash, right? So if you are taking center as A dash, you have to rotate from B dash to A dash or A dash to B dash only. If you are at A, you have to rotate from B to A or A to B. Okay, if you are taking your center as A, you have to rotate from B to A or A to B, not apart from A or B. Or means you don't have to rotate like this point up to this point, not like that. You have to rotate from, if you are at A and you have plan length, then you have to rotate from B to A or A to B, vice versa, right? So these are certain formula which I have written. I'll give you the hard copy of all of this. Another thing that you have to keep in mind is this A dash and A line, this vertical line. Okay, so on this vertical line, A and A dash are always on same vertical line. You have to keep in mind that. Similarly, B dash and B are always on same vertical line, right? So I have written this 6 point. A dash and A are always on same vertical line, and B dash and B are also on same vertical line. A dash and A on same vertical line, B dash and B on same vertical line. Now another thing that you have to keep in mind is one term that is called as distance between end projector. The term, it is called as distance between end projector. So what is that? It is the horizontal distance between vertical line AA dash and BB dash. So you can see here, this is the AA dash vertical line, this is BB dash vertical line. So distance between these two vertical line, the horizontal distance between these two vertical line, it is called as distance between end projectors, right? So you have to keep all of these points in mind. Then and then you can solve any problem of projection of line. Just you have to keep these points in mind and you have to grasp this figure. Now the position of this locus can be anywhere. If you have the locus of A dash here, locus of B dash can be here also, right? Locus of A can be here also, locus of B can be here also. Anywhere, anything can be happen, right? And you can place anything at anywhere according to the sum. And in the sum, you have the combination of all of this, right? In sum, the question will be asked in form of combination. So if you have given theta and phi and TL, then you have to find the other things. If you have EL, PL and alpha, then you have to find the other things. If you have alpha, beta and EL, then you have to find the rest of the things likewise. So in the next session, we are going to solve the problems with dimensions, right?